additional domain restrictions that you need to identify are the ones that are no longer apparent in their simplified form, okay? Meaning they represent holes in the graph, not asymptotes. Okay? So the first type of questions that you're going to see involving these are ones where you have monomials in the numerator and denominator. Okay? So you don't have to remove any common factors. You're just looking to cancel factors. And so if you're canceling factors and simplifying, okay, so there's no factors to cancel here. However, if you think of negative 54 and 45, they both share a common factor of 9. So if you think of that as negative 9 times 6, and here 9 times 5, that would be sort of the factoring that you're doing mentally when working with monomials. And then you have this q cubed divided by q squared. You can either apply the properties of exponents. When you divide exponents with the same base, you subtract their properties. Or because we're really canceling factors here, it's easier now to think of this as these two q's cancel with two of these, leaving just 1. Okay, so the 9's cancel. You're winding up with negative 6q in the numerator divided by 5. Do make sure when you have multiple factors, the preview should allow you to see that you have everything in the numerator that you want in the numerator, everything in the denominator. Any negative signs, please move up to the numerator when you express your answer. Okay. Now, notice in the second box, and all of these will contain secondary boxes that have the restrictions. Okay. If you cancel a factor completely from your denominator, you include that as a restricted value, right? You saw in the original form that q couldn't be 0. But once you simplified it, do we see that q can't be 0 in this simplified form? No, it got canceled completely from the denominator. Therefore, we have to identify that if we took that factor of q and solved for it, set it equal to 0, the restricted value would be that number 0. Now, if we took a look at this next example, same idea. You have these monomial factors, so we're just canceling any common factors here. So 5 goes into 55 11 times. These 3 t's cancel with 3 here, leaving 1. These 3 z's cancel with 3 here, leaving 1. So what we're looking at here is in our numerator, we have 11 t to the first, and in our denominator, we have a z. Okay? So when we're looking at the restricted values, did any variable get completely canceled from our denominator, or any factors get canceled completely from the denominator? The t's disappeared completely, right? So what value of t would give you a 0, division by 0? 0, so we do have to include that. And now, what value of z would give you division by 0? Also a 0, but is that apparent in our simplified form that z can't be a 0? Yeah, so you don't need to include that as an additional domain restriction. If that's the case, you're going to write d and e. Okay, and that doesn't mean that there's no restrictions on z. What it means is there's no additional restrictions on z that you can't already tell from that simplified form. Okay, but so this is what your answer would look like for these problems.